Good morning, sir.
Sir, you send it NCRT textbook PDF. We have to read that all pages.
Yeah, I am going to tell you what pages we are going to do. I have sent you NCRT book. I have sent one book on stereochemistry. I have sent problems, right? Okay. Now, because people don't have material to study, I wanted to send like that. This is your NCRT book. Page number 341. Page number 341. Stereoisomerism, they have given only one paragraph. The compounds that have the same constitution and sequence of covalent bonds but differ in relative position of their atoms or groups in space are called stereoisomers. This special type of isomerism is called stereoisomerism and can be classified as geometrical and optical isomerism. Only this much. On this, I have sent you one book called Stereoisomerism. Have you observed it in the group? Hello?
Yes, sir.
Hello?
We got the book.
Entire book we are going to discuss that. After completing the NCRT, we go to that, preserve that book. Tomorrow, don't ask me to send again. Okay? Okay? Now, fundamental concepts in organic reaction mechanism. A detailed study of all steps involved in the course of a reaction, where a starting organic molecule called substrate is converted to products. The detailed study of this path is called reaction mechanism. I repeat, the step-by-step study of conversion of a starting organic substance called substrate to a final product is called mechanism. Organic chemistry, we often study mechanisms. Okay, sir? So we are studying this fundamental idea. What is reaction mechanism? Study of all steps involved in the course of conversion of a starting organic substance into final product is called mechanism. Often in organic chemistry, we study mechanisms. To study mechanism, we need to be familiar with some terms. A sequential account of each step describing the details of electron movement, energetics during bond breakage and bond formation, and the rates of transformations of reactions into products is referred to as reaction mechanism. Knowledge of reaction mechanism helps in understanding the reactivity of organic compounds and in planning strategy for their synthesis. Okay. Fission means breakage. Breakage of a covalent bond is an essential thing to start with. Unless the existing bonds break, you can't get new bonds. So in the course of any reaction, the existing bonds between the molecules, atoms within a molecule should break so that new bonds are formed. When bond is breaking, we use a curved arrow. The curved arrow shows from where the electrons are going to where. This curved arrow indicates that both bonding electrons are going on to Br. So the bond breakage is heterolytic or polar. Br is becoming minus, carbon is becoming plus. Whenever a more electronegative atom is bonded to carbon, electrons go away from carbon. Carbon gets plus charge. This positively charged carbocation can be of three types: primary carbocation, secondary carbocation, tertiary carbocation. See, in ethyl, carbocation is linked to only one carbon, so it is called primary carbocation. In isopropyl, it is linked to two methyl groups. This is called secondary carbocation. In tertiary butyl, the carbocation is linked to three carbon chains. It is called tertiary carbocation. In fact, the more stable the carbocation, more readily the bond breaks. So how easily bond breaks, how rapidly a reaction happens depends on the stability of carbocation. So many factors influence the stability of carbocation, like inductive effects, resonance effects. These effects we study shortly. But at the moment, I would say the tertiary carbocation is always more stable than secondary carbocation, which is more stable than primary carbocation, which is more stable than methyl carbocation. That's a point. What stabilizes it, we see shortly. At the moment, I would also say that whenever there is a carbocation, the C plus carbon is sp2 hybridized. It is like a triangle, like trigonal planar. At the vertices of the triangle, hydrogens are there. Above and below pure p orbital is spreading, which is empty. This is sp2 hybridized carbocation. Notice carbocation never forms at bridgehead. You know what is bridgehead? In a bicyclic compound, the starting point where two bridges start. Carbocation can never form at bridgeheads because in carbocation, HCH angle is 120. At a bridgehead where two rings are joining, angle can never be 120. So carbocation never forms at bridgeheads, even if it is bound to FClBr. When the carbon is linked to less electronegative atoms like lithium, sodium, magnesium, or when it is linked to Z, the electrons are going to carbon. So the carbon gets minus charge and gets plus charge. The carbanion forms when carbon is linked to less electronegative groups. when carbon is linked to copper, when carbon is linked to silver, when carbon is linked to magnesium, lithium, the carbon gets electrons. Here the complete sigma electrons are going to carbon. The carbon ion is stabilized by certain factors. The factors that stabilize carbocation are exactly opposite to factors that stabilize carbon ion. So order of stability of carbon ion is exactly reverse to the order of stability of carbocation. This type of bond breakage where somebody is getting minus, somebody is getting plus is called heterolytic or heteropolar or ionic cleavage. If a bond is breaking such that both atoms are getting one electron, it is indicated by fish hook arrow. R gets one electron and X gets one electron. Fellow which has one electron is called as free radical. The order of stability of free radicals is exactly same as the order of stability of carbocations. Always free radicals are formed due to high temperature or due to the presence of light or H2O. Are we clear about it, sir? Now, a nucleophile is somebody who is fond of attacking nucleus or positive center. A nucleophile, because it is attacking positive center, it means it has negative charge. Sometimes it may not have negative charge, but it has donatable lone pair of electrons. For example, Cl minus, Br minus, I minus, Cn minus, NO2 minus, any minus ion can attack positive center. Water, oxygen has two lone pairs, H2O. Ammonia, nitrogen has one lone pair on nitrogen. All these fellows which have lone pairs can also attack positive center. Anybody who is attacking positive center is called nucleophile. And nucleophile always attacks the centers which are positively charged, which are fond of electrons. They are called electrophilic centers. Nucleophiles attack electrophilic centers. Electrophiles attack nucleophilic centers. Like ladies marry gents, gents marry ladies in India at least. I think so. A reagent that takes away an electron pair is called electrophile. An electrophile is one who loves electrons. It is loving electrons because it has positive charge. So, sir, what is a nucleophile? Nucleophile is somebody who attacks or who loves nucleus or positive center. Who will love nucleus or positive center? Fellow who has negative charge or who has lone pairs. Any negative ion, any molecule with a lone pair of electrons on atoms can be nucleophile. Cl minus, Br minus, I minus, NO2 minus, X minus, all these are nucleophiles. Also, ammonia, nitrogen has lone pair. Water, H2O, oxygen has lone pairs. These are all nucleophiles. An electrophile is essentially who loves electrons. It loves electrons because it has positive charge, and positively charged fellows beg electrons like CH3 plus, like Cl plus, so on. Those beggars of electrons are called Lewis acids. Those which donate electron pairs, nucleophiles, are called Lewis bases. Let us look at water is a nucleophile because it has two lone pairs on oxygen. Trialkyl ammonia is a nucleophile because it has a lone pair. Hydroxide ion is a nucleophile. Cyanide ion is a nucleophile. Carbon ion is a nucleophile. H minus is a nucleophile. On the contrary, somebody who has positive charge, CH3 plus, or when carbon is locked to double bond O, oxygen takes away pi electrons, carbon gets plus charge. So center where carbon already has positive charge, center where carbon is likely to get positive charge are called as electrophiles. In CH3X, X is more electronegative than C. It takes away electron. Carbon is likely to get positive charge. So it is called as a electrophilic center. Look at this. Using curved arrow notation, show the formation of intermediates. In CH3SCH3, electrons can go towards sulfur because sulfur is more electronegative than carbon. See how I am showing. Due to this movement of electrons, carbon gets plus charge, SCH3 gets minus charge. In CH3CN, C is bonded to nitrogen by triple bond. Nitrogen is more electronegative. That permits the carbon to take away electrons from CH3. So electrons are flowing like this. In methyl copper, copper is less electronegative than carbon because metals are less electronegative. Electrons are coming onto carbon. Now, next question. Please notice before we go to next question. A nucleophile is one which has minus charge, which can donate electron pair. An electrophile is one which has positive charge and which loves electrons. There are some molecules which can donate electrons, that is nucleophiles. They can also accept electron pairs because they have empty orbitals. Such strange fellows which can act as nucleophile as well as electrophile are called amphiphiles. Example, SO2. It is not there in the book I gave you. What is SO2? SO2 sulfur has a lone pair, so it is a nucleophile. In SO2, sulfur also has empty d orbitals, so it can take electron pair. It is also electrophile. So,
Sir, sulfur is amphiphile.
please, avoid touch. Hello.
Sir,
What is
sulfur dioxide
amphiphile?
is amphiphile.
Amphiphile is SO2, for example, SnCl2. Molecules which can donate electrons, nucleophiles, which can also accept electron pairs due to empty d orbitals. Example, SO2, SnCl2. So, you can identify nucleophiles, you can identify electrophiles, you can also identify amphiphiles. Look at BF3 is a electrophile because boron is electron deficient, 13th group element. It has only 6 electrons. It wants to beg 2 more. AlCl3, BF3, BeCl2, electrophiles. Cl plus, CH3, C double bond O. Oxygen takes away electrons, C plus. NO2, all they are electrophiles. In CH3CHO, the C
Hello, sir. Hello.
Sir, you are not audible, sir.
Hello. Hello. Hello.
Sir is not speaking. Not speaking.
Why?
Sir,
कौन है रे भाई तू?
निशानियां करेंगे कारण